Our first topic that we're going to discuss is problem-solving strategies. The whole point of physics is to be able to solve new problems that you've never seen before, and it's one of our main goals for the course. In addition to being able to just solve physics problems, we also want you to be able to solve any kind of word problem, whether they be quantitative or not. The system that we're going to talk about will enable you to solve a variety of different types of problems in any science field. We'll use an algorithm-like system for problem solving, which has an acronym of GOAL. GOAL stands for gathering information, organizing your approach, analyzing the problem, and learning from your efforts. We'll do an example problem where we use all of these parts of GOAL to solve a question that is not a physics question, but is rather kind of an everyday type of question that needs algebra to solve it. So what does it mean to gather information? Well, this is the first thing you do in approaching a problem. You have to understand the situation. So you want to read the problem carefully and try to figure out exactly what the question is asking. You should carefully study any drawings that accompany the problem, but remember that sometimes the pictures can be misleading. From reading the problem, you should try to determine what pieces of information are given. For instance, are there any data numbers given that you can use? And are any of these numbers not necessary to solve the problem? You should also know what units to expect. In science, we use SI units, and you should be familiar with these from many of your other courses. Don't forget to use outside information from your own experiences and common sense. For instance, there are a number of words that are in word problems that are giving you quantitative information even though it might not seem like it. For instance, if something says that an object is at rest, then you know that the velocity is 0. If they say that it starts at rest, then you know the velocity is 0 at some time, and you usually call that time 0. You can also bring in any information from your own experiences to help you figure out if your answer is correct or if what you're doing is going in the right direction. For instance, if you're finding that gravity is pulling an object upwards towards the ceiling, then perhaps there's something wrong with your plus and minus signs in your problem. You should also be able to figure out what a reasonable answer should look like, and if there are any cases which are easy to solve, you should be able to find those out. So let's do an example. We're going to use this example of a recent news article in the New York Times about the movie The Interview. As you probably know, Sony Pictures did not release The Interview in theaters, but instead chose to release it on the web. Sony Pictures said that The Interview made $15 million in online sales and rentals during its first 4 days of availability. They didn't say how many of the total sales represented $6 digital rentals versus $15 sales or purchases of the movie, but they said that there were 2 million transactions. Even though they don't tell us how many rentals versus sales there are, we can actually use all of the information given in this article to figure it out. The question that we're asking is, how many more rentals than sales of The Interview were there? So let's gather our information. Some of the things are pretty obvious. So for instance, 15 million total sales, rentals cost $6, sales cost $15, and a total of 2 million transactions. These are the numbers that we want to gather for the information. We can write them out like this. Total money made was $15 million. Total transactions, which are rentals and sales together, were 2 million. One rental equals $6 and one purchase equals $15. The question that we want to answer is how many total rentals and how many total purchases, and ultimately we want to subtract these numbers in order to figure out how many more rentals than sales there were. Step 2 is organizing your approach. From step 1, you should have a really good idea what the problem is about, but now you need to think about what to do next in order to solve it. First, you should think if you've ever seen a question like this before. If you're able to classify the problem, it will make it much easier to lay out a plan to solve it because you can use things that you've learned from other problems that you've solved. You should be able to make a quick drawing of the situation, especially for physics questions where there are things like balls rolling down inclined planes or things dropping off the sides of buildings. That drawing will actually give you a lot of information and help you to organize how you're going to solve the problem. You should label important events in your sketch. So if something starts at time equals 0 and then changes at some later time, you can label that in your sketch. You should indicate any known values, and those are given to you in the question typically, or they're things that you should know, such as room temperature. And some kinds of problems require specific drawings like free body diagrams, and we'll talk about those in the courses as it goes along. Let's go back to our example and figure out how we will organize our approach. So we already know that we've gathered some information about this question, but what we want to do now is actually organize it into a way that uses numbers and variables that we can put together in a system of equations. So for instance, the total money made, $15 million, can be written as M total for money total is equal to 1.5 times 10 to the 7th. We can say that the total transactions of rentals and sales were 2 million, so we can call that T total is 2 times 10 to the 6th. We know that M total must equal to the number of rentals times $6 plus the number of purchases times $15. And we know that the total transactions are just the number of rentals plus the number of purchases together. Now we've organized our question into a series of equations that we can solve. It's time to analyze the problem, step 3. Because you've already categorized the problem, it might be easy to just apply what you know from a previous problem to this problem. We can use algebra to solve for the unknown variables in terms of what's given and substitute in the appropriate numbers at the end after we've rearranged all of the algebraic equations using letters only. Alright, so we go back to our problem. We have our M total, our T total, and then an expression for M total using the number of rentals R and the number of purchases P, and the same thing for the total number of transactions. We can put M total, we can know that M total is equal to M total, so that gives us 1.5 times 10 to the 7th equals this equation R times 6 plus P times 15. We can do the same thing with the second equation. We know that T total equals T total, so that means that 2 times 10 to the 6 equals R plus P. And now we have a system of 2 equations with 2 unknowns. R and P are unknowns. Using straight algebra, we can just solve equation 2 for R or for P. I'm going to solve it for R. And then we can substitute R into equation 1. So now we have R is equal to 2 times 10 to the 6 minus P, and we can plug that into the first equation. And we can solve for P from that first equation because now equation 1 only has P's in it, so it's one equation and one unknown. We're going to continue to rearrange these equations. So these are our 2 equations. Again, just a recap of what we've done to scoot everything up, and we have more room. So now we're back for solving for P. We've now multiplied in the 6 so that we have 6 times 2 times 10 to the 6, which gives us 12 times 10 to the 6, or 1.2 times 10 to the 7th. And then we say minus 6p because we multiplied the 6 in. We can now gather the p's together on one side and gather all the numbers that don't have p's together on the other side. So we get 1.5 times 10 to the 7th minus 1.2 times 10 to the 7th is equal to 15p minus 6p. Putting that all together, we get 3 times 10 to the 6 equals 9p, and dividing that out by 9 on each side, then we get p is equal to 3.3 times 10 to the 5th. This is the total number of purchases of the interview movie. So there were 3.3 times 10 to the 5th purchases, but how many rentals? We can plug p, that is now known, into equation 2, which has already been rearranged to solve for r, and we can find that there were 1.7 times 10 to the 6 rentals. Finally, we know that there are 3.3 times 10 to the 5th purchases, there are 1.7 times 10 to the 6 rentals. We need to figure out if we're done. So let's reread the question. And it says, using the information in this article, how many more rentals than sales of the interview were there? Asking how many more rentals than sale means we want R minus P. So R minus P is 1.3 times 10 to the 6. So that means there were 1.3 million more rentals than sales. I guess nobody really wanted to buy the movie, they just wanted to see it one time. Now that we've gone through steps 1 through 3, we can talk about step 4. This is where you learn from your efforts. In a lot of ways, this is actually the most important part, and it's also the thing that nobody ever does. In the real world, in particular, if you were actually doing science, after you solved a problem, you would want to look back at it and figure out if it makes sense and figure out how you got there and why you got there. In the academic world, you should try to figure out what the instructor was thinking about when he or she or I assigned you that problem. Hopefully you learned something by doing it, but can you figure out what you learned? You should examine the numerical answer. Does it make sense? For instance, in our example, if we had had an answer that was larger than the sum of the transactions, then we would know that we did something wrong, maybe using a plus sign when we should have used a minus sign. We can also look at the units. In our case, we had units of dollars and also units of purchases or rentals. These are units even though they don't seem like units, and you should make sure that you carry them through your answers as you're answering the problem. For more complex problems, which you will see in this class, you may have to apply the 4 steps of the goal process recursively. So what that means is you may have to use the goal process one time to get an initial answer and then use that answer to solve a larger part of the problem. You will be asked to do multi-step physics questions in this class. So let's use the learn from our efforts part of goal for our recent example. Do our answers make sense? What are the units and what did we learn? So we had 3.3 times 10 to the 5th purchases, 1.7 times 10 to the 6th rentals. That makes sense. Those two numbers add up to 2 million transactions, which is what we would expect. And neither of these numbers is larger than 2 million, and when multiplied by their respective amount for rentals or for sales, neither of them is larger in themselves than 15 million. So it seems like this is a reasonable answer.